easiest application of DNA electrophoresis technique is the separation DNA fragments. An agar gel of low melting point is used. The gel fragments contain the DNA to be purified, cut, melt, and by organic extraction remove the agarose. The DNA is in the aqueous phase. Fragments that are of interest can be purified from the gel various extraction techniques and uses for different purposes. Cloning, sequencing, mutagenesis, fusion with other fragments used as proofs. One of the problems of recovered DNA from agar gel is the amount. The lower is the amount of DNA the recovered decreases proportionally. The result of the process of preparation and purification of the genetic material is to rearrange the maximum of DNA product-free high molecular weight proteins, phenol an inhibitor of restriction enzymes, and Taq polymerase. The high-purity DNA is a requirement for techniques of molecular biology and PCR. There are different purification methods like magnetic probe, hot phenol, agarose degradation using agarose enzymes, DNA recovered by electrolysis in a membrane, DNA recovered by electrolysis in a dialysis bag, DNA recovered by electrolysis into a tramp of salt, silica columns, and DNA fragments purification with G.2 agarose. The following table are shown advantages and disadvantages of these methods.
There are various methods for PCR cleanup such as ethanol, Vídeo column purification, and enzymatic purification. Ethanol purification represents the most cost-effective method but tends to be laboring, whereas column purification is widely used for different applications. However, it faces challenges like clogging, large elution volumes that require transferring samples in and out the column, which represents losing sample. And this can be not the best method when there are limited starting materials. Finally, enzymatic purification implies an exonuclease and deactivating it thermally, increasing the temperature at 80 Celsius. This procedure occurs in a single step and a single tube, which is advantageous among the other methods, and it is also affordable.
The purified DNA fragments which have a molecular weight less 1 kilo base column extraction kit are the best option. Gel extraction kits like the ones mentioned before ensure a recovery percentage up to 95% and have a high capacity of DNA binding. On the other hand, to purify high molecular weight DNA samples, the most useful method is to be the agarose degradation with agarose enzyme, because it's the most recommended for high molecular weight samples.
Results. Figure 1 is a photograph of a 0.8% agarose gel. On the first lane, 5 microliters of 1 kilo base in vitro gene marker were loaded, and on the lane 4, 5 microliters of the PCR product were loaded. On the other hand, figure 2 shows a 1.4% agarose gel, in which lane 1 corresponds to 2 microliters of 100 base pairs in vitro gene DNA ladder, and on the second lane, 5 microliters of the PCR product were loaded. On both figures, the PCR product degradation is depicted on a pink rectangle and the amplified product on a green one. Comparing both results from the figures, the purified PCR product on the figure 2 shows a well-defined band that was not previously achieved on the figure 1, in which protein contamination is observed. This can be verified on the following table, which summarizes the UV-Vis quantification, contrasted the optical density at 280 nanometers, which indicates the presence of proteins. The DNA extracted gives a value of the 0.097, while the PCR product that was purified gives a negative value. In addition, the final concentration of the DNA was lower after using the purification kit, indicating high yields of purity.
As observed in Figure 1 and 2, one can distinguish clearly that the purified PCR product has a better quality compared to the one in Figure 1. The band on figure 2 has a better quality and definition. Almost no degradation can be observed, and definitely it can be said that the purified PCR product is about 450 base pairs. So in few words, the sample obtained by the purifying kit has a higher purity than the original DNA sample. According to Adams 2003, the most common technique to determine DNA yield and purity is also the easiest method, absorbance. Absorbance readings are performed at 260 nanometers, where DNA absorbs light most strongly, and the number generated allows one to estimate the concentration of the solution. To ensure the numbers are useful, the A260 reading should be between 0.1 and 1. In this experiment, the absorbance was of 0.147. Contaminants such as RNA and proteins, which absorb light between 260 and 280 nanometers, can lead to a higher number of absorbance. This means that if the A260 reading number is used for calculation of yield, the DNA quantity may be overestimated because of the contaminants. The total yield of purified DNA was of 6%, which is a low number, but again this may be influenced by the presence of contaminants and possibly a loose calibration of the equipment used. The results may be attributed to a poor performance during the preparation of the samples. Also, according to Harris 2003, good care of the equipment, for example, cleaning and keeping away dust, is critical for the maintenance of the spectrophotometer. Filtering the solutions and manipulating the buckets with care and cotton to avoid scratch are important for the final reading and results, as well as proper pipetting skills and calculation of the solutions.
Conclusion. Using the standard PCR or gel extraction kits will both clean a PCR product sufficiently for downstream applications, but which to use depends on what is wished to be done. If one is absolutely sure there is a single product from the PCR, one can skip running the whole sample on a gel and only run a small fraction to validate the PCR reaction. The rest of the sample can be purified using the PCR purification kit. On the other hand, if there is no certainty of a single product or additional minor products are produced from your PCR reaction, it is best to separate the PCR products from the reaction using an agarose gel, excising the band of interest and then using the gel extraction kit to purify the DNA. In the second case, the only reason to use the PCR purification kit is to concentrate a sample so that all the reaction product can be loaded into a single well of the gel.